In this video, let us solve for x given x raised to power 6 is equal to 2 raised to power 6. So we have x raised to power 6 is equal to 2 raised to power 6. I'm going to move this 2 raised to power 6 to the left hand side to give us x raised to power 6 minus 2 raised to power 6 is equal to 0. X raised to power 6 can also be written as x raised to power 3 raised to power 2. Same thing with 2 raised to power 6, I can also write it as 2 raised to power 3 then raised to power 2 is equals to 0. If I let x raised to power 3 be represented by, say, p, and let 2 raised to power 3 be represented by, say, q, then we can immediately see difference of two squares as this becomes p squared minus q squared is equal to 0. And to factorize this becomes p minus q times p plus q is equal to 0. So after this factorization, there's actually no need for these variables, so I can put back x raised to power 3 and 2 raised to power 3 in this factorization. Therefore, this is x raised to power 3, so this is x raised to power 3 minus q here is 2 raised to power 3, and then times x raised to power 3 plus 2 raised to power 3 is equal to 0. Therefore, this implies that either x raised to power 3 minus 2 raised to power 3 is equal to 0, or x raised to power 3 plus 2 raised to power 3 is equal to 0. So we'll call this case 1, and we'll call this case 2. In the first case, we have difference of two cubes. To factorize difference of two cubes, recall this identity, a raised to power 3 minus b raised to power 3. You can factorize this as a minus b times a squared plus ab plus b squared. So this then becomes x minus 2 into brackets x squared plus 2x then plus 2 squared is equal to 0. We'll tidy this up to give us x minus 2 into brackets x squared plus 2x, 2 raised to power 2 here is 4, then equal to 0. So again, we say either this is equal to 0 or this is equal to 0. From here, x is equal to 2. And here we need to solve this quadratic equation to get any other solutions in this. So let's call this x1, which is real value, now we solve this quadratic equation. We compare this with the general quadratic equation, ax squared plus bx plus c is equal to 0. To get the coefficients a, b, and c, a is 1 when compared to this, b is 2, and c is 4. Using the general quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac, square root of that, divided by 2a. Then we already have our a, b, and c. We just go ahead and substitute into this formula. Then we get x is equal to minus, b is 2, so we say 2 plus or minus square root of 2 squared minus 4 times a is 1 and c is 4. All divided by 2a, which is 2 times 1. So x is equal to negative 2 plus or minus square root of 2 squared is 4. 4 times 1 times 4 is 16. All divided by 2 times 1 is 2. So we get x is equal to negative 2 plus or minus square root of 4 minus 16 is negative 12. Then divided by 2. So we get x is equal to negative 2 plus or minus 12 here is 4 times 3, so we can write this as square root of 4 times negative 3, square root of that, all divided by 2. Then we write this as x is equal to negative 2 plus or minus. Let's separate this radical, so we have square root of 4 times the square root of negative 3 divided by 2. So this gives us x is equal to minus 2 plus or minus square root of 4 is 2, so we have 2. Now square root of minus 3 here is going to be square root of 3 times I, because of that negative, then divided by 2. So we separate this division to give us x is equal to negative 2 over 2 plus or minus 2 root 3 I divided by 2. Then 2 here is 1, 2 here is 1, 2 cancels 2 here, so we have x is equal to minus 1 plus or minus root 3i. So we're going to have x2 is equal to minus 1 plus root 3i, and then we have x3 is equal to minus 1 minus root 3i. Now for case 2, we have x raised to power 3 plus 2 raised to power 3 is equal to 0. By identity, a raised to power 3 plus b raised to power 3 can be factorized as a plus b into a squared minus ab plus b squared. This will imply that this now becomes x plus 2 into bracket x squared minus 2x plus 2 squared is equal to 0. X plus 2 into bracket x squared minus 2x plus 4 is equal to 0. This implies either x plus 2 is equal to 0 or x squared minus 2x plus 4 is equal to 0. And from here we get x is equal to negative 2, which is another real solution. We call this x4. And then we go ahead and solve this quadratic equation again to get the last two solutions for this problem. Comparing this to the general quadratic equation, you see the first, or the coefficient of x squared here is 1, coefficient of x, which is b, is -2, and the constant time is 4. So x in this case is going to be minus b, which is -2, minus b, so minus 2 plus or minus square root of b squared, which is -2 squared, minus 4 times a is 1, and c is 4, then square root of all of that, divided by 2 times a, which is 1. So x is equal to minus times minus is plus, so we have positive 2 plus or minus square root of -2 squared here is 4, minus 4 times 1 times 4 is 16, square root of that, divided by 2 times 1 is 2. So we get x is equal to 2 plus or minus square root of -12. 4 minus 16 is -12. Then divided by 2. So x is going to give us 2 plus or minus. Here we did something similar to this, and we got 2 root 3 times I, then divided by 2. Let us separate this division. This will give us x is equal to 2 divided by 2 plus or minus 2 root 3i divided by 2. 2 cancels 2 here. 2 divided by 2 here is 1. Then we have x is equal to 1 plus or minus root 3i. Then we can split that to give us x5 now, equal to 1 plus root 3i, and then x6 is equal to 1 minus root 3i. Bringing us to the end of the solution, giving us all 6 possible values of this problem, with 4 being complex solutions and 2 real solutions. Thanks for watching. Please like and share, and remember to subscribe to my channel if you have not done so already, and I'll see you in my next video. Bye.